Hi, Year 7. It's a really exciting day. We're going to talk about pi. No, not that pi. This pi. Most important number possibly in maths. Why is it so important? Well, we're going to look at that now, and I'm going to let Mr. Collins take that over. Over to you, Mr. Collins. Thanks, Mr. Collins. So, what is pi? Pi is a number that you may recognize, 3.14159, etc. Goes on forever. It's something called an irrational number. But why is it so important and why do we care about it? Well, every circle in the world has got pi involved in it somehow. It's because no matter how big the circle, it could be the circumference of the Earth or the circumference of the clock in my room, or it could be the bottom of this sauce bottle. They all have something in common. If you have their diameter and you multiply it by pi, you get the circumference, no matter what the size of the circle. And that's amazing. What else is amazing is that this isn't just a whole number, like 3 or 4 or 7. It's an irrational number, which means it can't be written as a fraction. It's got this decimal that repeats on forever and ever and ever and ever and ever and ever and ever to infinity, with no reoccurring pattern. That's why it's kind of amazing, because it's nature's number, and yet it's not a simple whole number. Why isn't it just 10? Well, how do we find it? How can you find it? If you take the circumference of a circle, so measure the distance around the outside, and divide it by its diameter, so the distance through the center to either side of the circle, you will get pi. Now, you don't even need a measuring tape for this. I decided to do it with the new fountain down by the new school. So have a look at this. I measured it in feet. Okay, so you saw that I walked around, I think it was 22.5 steps. That was my circumference. And I'm going to divide that now by my walking diameter, which I think was about 7.5 steps. So my unit here is steps. As long as they're both in the same unit, I can do this calculation. So 22.5 divided by 7.5, and I get 3, exactly. Now, I also measured the circumference of my mug. How did I measure that? Well, I got a bit of string, and I measured around the outside. So I held it around the outside, and then I put the string against a ruler, and I got the distance in centimeters. So that's how you measure around a circle. That distance in centimeters was 18.9 centimeters. And then I divided it by the diameter across. So I got a ruler and measured the diameter across. And that was 6.2 centimeters. Okay? When I did 0.9 divided by 6.2, I got 3.048. Now both these are pretty close to 3.14159. They're about 1/10 off both my mug and that new fountain that's out there. Why are they not perfectly 3.14159? Well, now that you're all adept at accuracy issues, you could probably see some problems with both my measurements. The walking around the fountain, perhaps I didn't walk in a perfect circle. It seems like my diameter was a bit too big and my circumference was a bit too small. Maybe I should have walked further closer to the outside. Then I would have risked falling off and looking like an idiot. When I measured the mug, perhaps a piece of string is not the most technical of or precise of measurements. Maybe I could have done a different thing. Maybe I could have used a compass somehow. But they're close. I want you, in task number 1, to measure something in your house, either just walking around the circle and then walking through the diameter, or get a piece of string out and measure a mug or a clock or something that's perfectly round, and see does pi work for you. See if you can get the closest to pi. You're looking for this perfect answer. Maybe you should. Earth, as a circle, is 3.1412, I think. So it's almost a perfect circle. So it can be a test for a perfect circle as well. So that is pi. And we use pi a lot when we're dealing with circles because it's constant, mathematical constant, it doesn't change. Therefore, if we know the diameter of a circle, if we just multiply it by pi, because it's always the same, we can get the circumference of the circle. That's how we find the circumference. We get the diameter of any circle and multiply it by 3.14159. Now, it's a bit of a cumbersome number, a bit awkward. Sometimes they use a symbol. It's the diameter multiplied by the symbol. So maybe you've seen that symbol before. It's our symbol for pi. That's that number. Or they round it off to 3.14. Sometimes they use a fraction representation, but it's not very accurate. Okay, so you can give your answer 2 ways. Diameter multiplied by the full decimal, or diameter multiplied by symbol, pi. It's like x in a way, but we know what it means. We know what this variable is. It's 3.1415926 etc. Okay, so you can give your answer in 2 different ways. As a decimal, using this way, or in terms of pi, using that way. Now, let's have a little look at how I do that. So I'm going to look at 2 very quick questions. Let's draw a circle. I have a diameter of 10 centimeters in the first one. In the second one, I am only given a radius. What's a radius? Well, a radius is half a diameter. It's just the distance from the center to the outside of a circle. That's a radius. And let's say that is 8 centimeters in this particular circle. So let's get the circumference of both these. Circumference here will be its diameter. Circumference is going to be its diameter, 10, multiplied by, well, 3.1459, or I can just say 10 times pi. Now my answer, as a decimal, or we don't need a calculator for this, because we just move the decimal place 1, is 331.4 centimeters. And my answer for this one, in terms of pi, is just 10 pi. And that's how I'd write it. In terms of pi, it's probably a lot more easy to write. Which is more accurate? 31.4 or 10 pi? It's actually 10 pi, because it includes all the decimals, even though it doesn't say it. It includes all the decimals, pi does. Okay? So in the second example, where we're just given the radius, well, I need to double the radius in order to find the diameter before I start. So the radius is 8 of this, which means the diameter is twice as big. It's 16. That's 8, so it would be another 8 to the other side, and that'd be a full diameter of the circle. And then I go about the same process again here to find the circumference. And you can figure that one out yourself, multiplying by 3.14, 16 by 3.14, or 60 times pi. Now finally, some of the questions that you will get won't be a full circle. So if you find the diameter of half a circle, you need to get this answer and divide it by 2, so a semicircle, or a quarter circle, something like that, you would have to divide by 4. You'd get the full circumference and then divide by what fraction you have. Now sometimes they ask you to include this part, which would be not part of the circumference, but would be part of the perimeter of the shape, the outside of the shape. So sometimes they ask you to include these lengths, so you'd have to add them on afterwards. So that's in the more difficult, maybe blue level questions, you'd have to do that with some composite shapes. Okay, so to conclude from this, a couple of things you definitely need to know. First of all, diameter is the full distance across a circle. Our radius is half the distance from the center to the outside. The circumference is the total distance around a circle. Pi is 3.14, rounded off. To get pi, you get the circumference of any circle and you divide it by the diameter of the same circle. And you should get pretty close, and that's a task for you you'll have to do. Then you'll be given some questions where you need to multiply the diameter by pi to get the circumference. Multiply the diameter of a circle, multiply it by pi to get it. Okay, good luck.
So, thanks Mr. Collins. So just to conclude, the circumference can be written a couple of ways. Pi times the diameter, which is sometimes called pi d, and or pi times twice the radius, and that'll be written in maths 2 pi or, so 2 multiplied by pi multiplied by radius, and this is pi multiplied by diameter, and that's how you work out the circumference.